All right, let's look at the translated series solutions. All right, here's an example. All right, so you have a differential equation with initial value conditions, right? But notice that initial value is given at x equals 3, right? And I like x equals 0 better than x equals 3. So we can just shift the variables a little bit so that it's going to be back to x equals 0, right? So let's do this. So we're going to use a substitution. Let say t equals x minus 3, right? Then you notice that if you take the derivative of say dt with respect to x, it's going to be equal to 1, right? So which means that if you look at the derivative y prime, which is dy over dx, which is the same thing as dy over dt times dt over dx, right? But we just said that dt over dx is just equal to 1, so which means that derivative with respect to x is same as derivative with respect to t. Alright, so let's rewrite this differential equation and the initial value conditions in terms of t. Alright, so let's see, I'm going to actually rewrite this as x equals t plus 3, right? Alright, let's plug it in. And x squared would be t plus 3 squared, so you will get the t squared plus 6t plus 9, right? Minus 6x is minus 6t minus 18, right? Plus 10, right? Then you have y double prime, so but this is with respect to x. We're going to turn into with respect to t, but we just said that they are basically the same, so I'm abusing the notation a bit, but I'm going to use y double prime, but this is with respect to t, right? Then x minus 3 is t, so it's going to be negative 4 y prime. Then you would have negative 4t y prime and a plus 6y equals to 0, right? Then you can see that we can simplify a bit, 6t and then negative 6t, and 9 plus 10 is 19 minus 18, so you're going to have t squared just plus 1, right? And the initial values are going to be, instead of, when x equals 3, t equals 0, so I'm going to just write that y of 0 equals to 2, and y prime of 0 is equal to 0. Alright, so let's use a power series method to solve this differential equation. Alright, so this is going to be, right, so you would have t squared plus 1. Alright, second derivative is summation, n goes from 2 to infinity, n times n minus 1 times cn, t to the n minus 2, and minus 4t times summation, right? First derivative starts from 1 to infinity, n cn, t to the n minus 1. And then you have a 6 times y, which is summation, n goes from 0 to infinity, cn, t to the n, which is equal to 0. Alright, so let's multiply this out first. So you have t squared times that is going to be a summation, n equals 2 to infinity, n times n minus 1 times cn times t to the nth power, because t squared and the t to the n minus 2 power gives you that. And 1 times that is going to be a summation. N goes from 2 to infinity. N times n minus 1 times Cn times t to the n minus 2. Right? Then if you put this guy in, so it's going to be minus summation. N goes from 1 to infinity. 4ncn, so t times t to the negative t to the n minus 1 would be t to the n. Right? Then plus last one is summation. N goes from 0 to infinity. 6cn t to the n. This is equal to 0. All right. So we want to make sure that everyone starts from everyone has t to the n, and everyone starts from 0. So the last one works great, and t to the n here. Then here n equals 1, but if you start from 0, when n equals 0, this term is 0 anyway, so we can actually turn this into 0. Alright, this one, you have a t to the n minus 2. So what we do is we're going to, instead of starting from n equals 2, we're going to start from 0. Then we can, since we decrease the starting number, we can increase the indices. So you have n plus 2 times n plus 1, cn plus 2, t to the n. Right? And this one has luckily t to the n there, and then we just have to start from 0, right? But when n equals 0, term is 0, n equals 1, term is 0, so we can just start from 0 because first two terms are 0 anyway, right? So that way everyone starts from 0 and everyone has t to the n, right? So we can combine it as a single summation. So this is going to be everyone goes from n equals 0 to infinity, right? Let's collect the Cn term. So you have from here, you have n squared minus n, and that will take care of this guy, right? Then you have negative 4n, so minus 4n Cn, right? So that will take care of that guy. And a plus 6Cn, so plus 6Cn, so you have a Cn, right? And that will take care of that. And the last one is this guy, right? So you have plus n plus 2 times n plus 1 Cn plus 2. Right? Then everyone has t to the n. Then this is equal to 0. Right? And we can simplify that. Then let's see, this is going to be just n squared minus 5n plus 6, and which can be factored out as n minus 2 and n minus 3. Right? That's 3. All right, so why don't we set this coefficient equal to 0 to get the recursive relation. So the recursive relation we get is going to be, I'm going to solve for Cn plus 2, which is equal to negative, right? N minus 2 times n minus 3 over n plus 2 times n plus 1 Cn. Right? So this is a recursive relation. Right? If you look at the initial condition, y of 0 equals to 2, this will give you C0 value. C0 is actually 2. Right? And the y prime of 0 equal to 0 gives you that the C1 equal to 0. Right? Since C1 is equal to 0, C3 is going to be 0, C5 is equal to 0, so all the odd terms is going to be 0 there. Right? So we just have to look at the even terms. Right? So let's observe the even term to see if we can detect the pattern. right? So let's try n equals 0, right? Then you will have C2 is equal to, you're going to have negative 2 times negative 3, 6. So it's going to be negative 6 over, and 2 times 1 is 2, and a C0. So that will be negative 3 C0, right? And n equals 2, then you have a C4 is equal to, but here's n minus 2, so 2 minus 2 is 0, so the whole thing becomes 0, right? This indicates that C6 is going to be 0, and a C8 is going to be 0, and so on, right? So, and also C0, we just found out that the C0 is 2. This is actually negative 6, right? So you have, so here's the solution, right? Y is equal to, right? C0 is 2, so it's going to be 2 is the constant term. And C1 is of course 0, and a C2 is negative 6. So it's a negative 6 t squared, and everything else is 0. But we cannot use t because this is a substitution, so we're going to go back to the original variable. So it's a 2 minus 6 times quantity. T is same thing as x minus 3 squared. Right? So this is the solution of the initial value problem. All right? That's it. I hope that this was clear.